Hello friends, welcome to our channel. In this lecture, I would like to explain another example, that is example 3 based on the losses of Prestress. Previously, I solved two examples, that is example 1 and example 2 from the chapter losses of Prestresses. So this is the same model only, but I choose different example. See here, a prestressed concrete beam. So it is better to write down the given data. Then only it will be easy to simplify the problem. A prestressed concrete beam 250 wide, which is denoted with B, and 360 deep. So this is also here. Okay, has a span of L equal to 12 meters. The beam is prestressed by steel wires of area. A will be given. In the previous problem, how it will be given? 6 numbers of 12 diameters. Then you can calculate 6 into pi d square by 4 like that. But here it will be given directly. A will be equal to 350 square. Okay, and provided an uniform eccentricity of E equal to 60 with an initial prestress of sigma I will be equal to, or sigma 0, you can take sigma 0 also, whatever according to your convenient. So sometimes they will given directly prestressing force like this, then the prestressing value will be directly you can take down here. So sometimes they will give some 6 numbers of 12 dia like that. At the time you can calculate it, the formula n into pi d square by 4. So this will be calculated area, you will get 6 into pi d square by 4 like that. But here what they will given? They will given sigma I and area. So you know the condition. Prestressing force will be equal to stress into area. So you can calculate prestressing force directly like this. Sometimes they will given like this with numbers. Sometimes they will provide area like this. Sometimes they will give stress also. Sometimes they will give directly prestressing force. So this is different here. You please remember, either they will give area also, you can calculate prestressing force. If they given directly prestressing force, you can substitute that value directly. Okay, along with that, what they are asked, determine the percentage loss of stress in the wires. So A, the beam is a pre-tensioned beam and the beam is a post-tensioned beam. So according to that, the data will be given. So EC will be the modulus of elasticity of concrete, S will be the steel elasticity of steel, that is 210 standard value. Okay, ultimate creep strength already I told, you can denote with ECC like this. See here also, so one will be given for pre-tensioned beam, another one will be given for post-tensioned beam. Okay, next shrinkage of strain. So you know already we saw in the last column, it will be denoted with EHS. Similarly, relaxation loss of stress also given. Shrinkage will be given, both one will be for pre-tensioned beam, another will be for the post-tensioned beam, and relaxation of steel stress also given. You can calculate that also. In the last example also I showed how to solve this one. So anchorage slip will be given, that is denoted with delta alpha. Okay, delta prefix alpha. Okay, then friction coefficient for wave effect will be k equal to 0.0015. So in the previous examples which I use only related to the pre-tensioned beams or only pre-tensioned post-tensioned beams, but this is the combination of the data given for both the pre-tensioned beams and post-tensioned beams. Okay, so what is the different? So here the data will be given, anchorage slip will be different, but they don't mention whether you can calculate for pre-tensioned beam or post-tensioned beam. First you know the concept of what is pre-tensioned beam and what is the post-tensioned beam. I will give simple example. For example, what is the pre-tensioned beam means, how it will be manufactured in the side. So there will be two bulkheads like this. So I will just explain briefly. So for pre-tensioned beam means what they will do. So pre-tensioned beams. So just remember the concept for pre-tensioned beam. First, in the molds, what they will do. These two are the bulkheads. Bulkheads. So first they will insert high tension steel wires. Okay, they will insert high tension steel wires. What happen? One end they will tied at the bulkhead. Okay, they will tie at the bulkhead. Another L, they will tightly pull here, then it will tie it to the another end. Okay, then what happen, they will pour entire concrete in the mold. So like this, so in the pretension bit what happened, the steel wire will be inserted before, after that the concrete will be poured. Okay, so after curing period obtained, again it will be released. So this will be compressed here. That is another concept. Just I will simply telling what is pretension beam and what is post tension beam difference. Okay, so first you see that only. So for pretension beams what happens, the steel wire inserted before only, after that the concrete will be poured. Okay, in the post tension beam what happens, you see, in the post tension beams, first in the molds they will place duct. Okay, like this, they will place some ducts like this, which shape you want. Okay, either parabolic shape or inclined shape or straight also, they will place ducts. Okay, then they will pour entire concrete, they will prepare the beams like this. After that, later what they will do, they will insert high tension steel wires in between like this. Okay, high tension steel wires after that. So in the, what is the difference between post tension beams? First the beam will be prepared by inserting the duct inside the beam. Later the high tension steel wire will be placed. So the cement grouting also done with the gaps also. So what is the major difference? Here you can clearly understood. In the pretension beam, the steel wire will be inserted before and the concrete will be poured. In the post tension beam, first the mold, the beam will be prepared. Later, high tension steel wire will be inserted. So that is the major difference between the pretension wire and post tension wire, post tension beam. Okay. Then here also asked the same concept. You can solve the both the examples. One will be pretension beam, another will be the post tension beam. So based on this, what are the losses here you will get? Okay, so here you will get the loss already in the last class also we did. One will be the elastic shortening, second will be loss due to creep of the concrete, third will be loss due to shrinkage of concrete. So these losses will be happening. Another will be relaxation loss also, relaxation loss also happen. So already in the last problem for pretension beams, we solved this one. And what about the anchorage slip? So before only we tied the steel wire to the bulkhead. So that is the major reason here we won't, it won't slip. So we won't get anchorage slip here, and we doesn't get because of the pretension beam. Uh, Prestress, the wire will be inserted before and tied at the bulkhead. You won't get a anchorage slip and friction effect. There will be no loss here. But in the post tension beam, we can insert the steel wires later. Here also one will be, so the after preparing the beam, the steel wire will be inserted. So here there is chances of anchorage slip and frictional effect, including these four losses: creep shortening, elastic shortening, shrinkage, relaxation. So that is the difference whenever the combination of the problems will be given. You please remember all this. Okay, for pretension beam they won't ask anchorage and frictional losses, but in the combination if they ask means you can skip that one and you can find out for that for the post tension beam. Then come to the problem. So entire problem remains same. For showing this difference only I choose this problem. Okay, first one, pre-tensioned beam. Okay, So before that, it is better according to the given data. So we want some basic values. Then that will be area. So if you want to find the area, what we will do? So they will given that rectangular section. If you want, you can find draw the diagram also. Area will be B into D. So you just keep that problem data in front and you can solve directly. So that will be 250 by 360. You will get the value in terms of mm square. Please simplify with your calculators. You will get exactly. So 9 into 10 to the power of 4. Similarly, you want moment of inertia, that is BD cube by 12. That one will be equal to 250 into 360 cube by 12. So what is the value? That is equal to 9.72 into 10 to the power of 8 mm power 4. And again, so what are the data required? I also told initial pre-stressing force. So you know the formula, stress into area. Stress value will be given, that is 1250, into area will be given, that is 350. Okay. So if you simplify, you will get around 437,500 newtons. If you want in terms of kilonewton, you just multiply with into 10 to the power of minus 3. Okay, 437.500 kilonewton. Clear? Then we also know in the last class we followed, we also find out modular ratio, that is M equal to ES by EC. That is ES will be given in the question, that is 210, and EC will be 35. So you will get modular ratio will be 6. Then after finding all this basic data, then you please find out the stressing concrete at the level of steel. Okay. So first to find out the basic, then only you can go that one. Stress in concrete, stress in concrete at the level of steel. So what is the formula? So already in the first problem only I told here P by A plus P square by I. So here it will be denoted with P naught because of the initial stress. We know, so P by A plus plus or minus P by Z, Z equal to I by Y. Here I in Y in terms of efficiency, that's why you will get I by E. So in the first problem only I told. So it is better you can remember the formula directly. Okay, then substitute the values. You know P will be equal to 437.5 into 10 to the power of 3. Then area will be 9 into 10 to the power of 4 plus again P will be 437.5 into 10 to the power of 3. Eccentricity will be given in the question, that is 60 mm. So here square. I will be equal to BD cube by 12, that is 9.72 into 10 to the power of 8. If you simplify, you will get the value. For this one, you will get 4.86 plus again for this one, you will get 1.62. So finally, you will get the value around 6.48 Newton per mm square. Okay, so these are the basic data which is required for solving the problem, that is for pre-tensioned beam and the losses for the post-tensioned beam. So you please remember all these values. Then first find out the pre-tensioned beam. Then first one, loss of stress due to elastic shortening of concrete. So I will write in shortcuts only. Please take down fully. Loss of stress due to elastic shortening of concrete. So what is the formula for this one? You know, M into Fc, that is stress in concrete at the level of steel. That one will be equal to modular ratio into Fc. Already we calculated here. You know, recently we calculated, that is 6.48. Okay, 6.48. If you simplify, you will get around 38.88 Newton per mm square. Similarly, next one will be creep of loss of stress due to shrinkage of concrete. Loss of stress due to shrinkage of concrete. So we know the formula also, that is epsilon cc for shrinkage of concrete, that is ehs into modulus of elasticity for the steel. Okay, so you here, you please take some care here, that is they will be given some different data. Shrinkage of concrete for pre-tensioned beam will be 300 and for post-tension beam will be 215 into 10 to the power of 6. So it is better, you can take down accordingly. For pre-tensioned beam they will given 300 ehs into 10 to the power of minus 6 into es will be 210 into 10 to the power of 3. So if you simplify, you will get around 63 Newton per mm square. Okay, so I think it is better to solve post tension beam here also aside. So we have the same data. It is better at a shot you can find both pre-tension beam and post-tension beam. So first one, due to elastic shortening of concrete, we will get M into Fc, modular ratio into Fc. So here also in the post-tension beam, elastic so what about the elastic shortening of concrete? So even though the formula will be same, you will get 0 here. Why? Because so already I told in the concept. So here at the bulkhead, um, the steel wires will be inserted later. So here there is a chance of getting shortening of the concrete. Why? Because after curing period happen, the steel wires will be released at the bulkhead. Then there is a chance of the concrete will be compressing here, because whatever the wire will be tightly pulled and tied at the bulkheads. After releasing, automatically the wire will be compressed. The high tension steel will be compressed. So based on that, the concrete also here you will get compressed. So here you will get elastic shortening of concrete. But in this case, if we observe, the concrete beam will be prepared before itself. Later, the steel wire will be inserted. So there is no chance of occurring more losses of the shortening of the concrete. That's why in the post tension beam you won't get that loss. Directly we can consider that one will be 0. And so what is the chance of getting here? Shrinkage of concrete will be there. So the formula will be same. So for that one the value will be given here for post tension beam. That one will be equal to 215 into 10 to the power of minus 6 into modulus of elasticity of concrete, 210 into 10 to the power of 3. So similarly, if you simplify this one, how much you will get? You will get around 45.15 Newton per mm square. Then next one will be the loss of stress due to creep of concrete. So the formula will be epsilon cc into fc into elasticity of steel. So epsilon cc will be given 22 into, sorry, for pretension beam it will be given, see the question, 45 into 10 to the power of minus 6 into modular ratio 6.48, sorry, this FC will be 6.48 into this elasticity of steel will be 210 into 10 to the power of 3. So finally, after simplifying, you will get 61.24. Similarly, here just the data will be changes. 22 into 10 to the power of 6, that is epsilon cc minus 6. Similarly, FC and EC will be same value, 6.48 into 210 into 10 to the power of 5. So here also that this is 5 only. So it is 10 to the power of 3 only, not 10 to the power of 5. So basically it is 2.1 into 10 to the power of 5. But here it will be given 210. Then we can consider directly 10 to the power of 3 only. If you take 2.1, that is 10 to the power of 5. Why? Because you will get 2 digits here. Okay, so you will get 10 to the power of 3 only here. So little bit confused here. Then if you simplify, how much you will get? So you will get around 29.94 Newton per mm square. So then next step is what we have to find: relaxation loss. Relaxation loss. So relaxation loss will be given 5%, means 5 divided by 100 into initial stress, that is sigma, that is 1250 equal to 62.50. So here also you will get same 5 divided by 100 into 1250. Same loss, that is 62.50. Still, what are the losses I told here? Both loss due to anchorage slip, that equal to 0, because in the pre-tensioned beam there is no chance of slip will be happens because of the high tension steel were straight at the bulkheads, and again you won't get frictional effect also. So that is also loss due to frictional effect will be 0 here. And what about here? So you will get anchorage slip, that is formula will be, slip formula will be delta alpha, delta fs equal to delta alpha modulus of elasticity of steel by L. So what is delta alpha? That is 1.25 will be given. And what about this ES? That is 210 into 10 to the power of 3. Then length of the span will be 12 meters. You can take down in mm, because you will get delta fs will be in terms of that is slip. That is the overall value will be 21.88 Newton per square. Then finally, loss of stress due to frictional effect. So how you will find out that frictional effect? So basically here the formula will be, you will get in terms of fx equal to f naught 1 minus kx. Then again if you simplify this one, f naught minus f naught kx. So finally f naught minus fx will be, considering after simplifying, directly remember this formula f naught k into x. So this is the simplified formula, better it is you can take directly. So after simplification directly you will get f naught kx, means that is initial stress, f naught here in the sense initial stress into k wave effect into x. So initial stress is 1250, k is the wave effect 0.00. So what is given in the question? 0.0000015 into x is the length of the span, that is 12 meters. So then if you simplify around you will get 22.50. So these are the losses occurring both in pre-stressed beam, pre-tensioned beam and post-tensioned beam. So it is better you can sum all these total losses differently in the pre-tensioned beam and post-tension beam. So what are the things occur here? One will be 38.88, another will be 63, another will be 61.24, another will be 62.50. Finally, you will get the value around 225.64 Newton per mm square. So that is for the pre-tensioned beam. So for the post-tension beam, you won't get elastic shortening here. Finally, you can add all the values taken from starting. That is elastic shortening will be 0 and this one will be 45.15. That is shrinkage. Creep will be 29.94. Relaxation will be 62.54. Slip will be 28.88. And this one finally one more loss will be frictional effect will be 22.50. So if you take add all the values you will get 181.97 Newton per mm square. So if you check in terms of percentages differently for post tension beam, what is the percentage loss occurs here? So this is the total loss happened. So what is the initial one? That is 1250 will be given into 100. You will get exactly the percentage, that is 14.56%. So similarly here percentage loss. So loss divided by, so already we know obtained marks by total marks like that into 100. So if you simplify around you will get 18.05% approximately. Maybe you will get some plus or 1 minus 1. Okay, so this is how you can calculate a pre-tension beam and post-tension beam differently. But it is better to remember some formulas directly. See here it is f naught into 1 minus kx. Directly you will get f naught kx after simplifying. Here some simplification will be there, but it is not possible for me to show all the simplifications here. That's why to make problem in less time, I did some. I taken directly the formulas directly. Okay, you please remember all these formulas. Then it is very easy to apply the values in that formula.